Hello, in this video let's discuss fourth question of today's contest. You are given an integer nums of length n and integer k. You must select exactly k distinct non-empty subarrays L2R of given array. Some subarrays may overlap, but the exact same subarray cannot be chosen more than once. The value of subarray nums is defined as maximum minus minimum. The total value is the sum of values of all the chosen arrays. Return the maximum possible total value that we can achieve. A subarray is contiguous non-empty sequence of elements within an array. The constraints are n is up to 1e5 and the values are up to 1e9 and k is less than or equal to 10 power 5, minimum of these both. So given an array, we can select any subarray I to j and we have to add maximum minus minimum from this to the answer, and then similarly we have to perform k times where we cannot select the same subarray exactly same subarray more than one time, but we can select overlapping subarrays. For example, in the first operation we can select 1 2 and in the second we can select 1 3 and so on, but we cannot select same more than once, and then care up to 1 5. So if the question says that we have to select different subarrays but not the same one exactly, then we will select the maximum subarray every time and answer will be simply k into difference. But here they can overlap, but same one we cannot select more than once. So what can we do now? So let's think about first subarray. So first operation, what will be the subarray that we'll select? In the first one, we'll select only the array with maximum element and minimum element in the subarray. So we'll select the maximum number and we'll select that index and we'll find the minimum number and then that index. So this will be the subarray that will perform the operation on. That is the first operation. Coming to next operation, which subarray we'll select? So we cannot select the same subarray as the before one because we selected the first one maximum and minimum in the first one. In the second one we cannot select that. So in second, what are the possibilities of selecting a second one? So if we clearly observe, we will select either maximum comma next min or next maximum comma minimum. Why? Because let's say 1 and 10 are least and the highest elements of the array, and the second least element is 2 and the second maximum element is 4. So if this is the case, then what will initially we selected 110. Secondly, which one we'll select? We want the maximum difference, so we'll select 1 4 or 2 4 or 2 10. We'll select 2 10. Why 2 10? Because the maximum is the 2 plus 10 is more than the next configuration which we'll select, because we have 110 and we have 2 4 also. So we selected 110. So the next operation can be 1 4 or 1 2 or 2 10 or 2 4. So these are the 4 possibilities left. So we selected 110. We want the maximum difference. So we'll either keep this maximum 10 in the same or we'll keep minimum in the same, because we want the maximum difference. So this the maximum can decrease with the least one so that the difference can be maximum of all the possible time. And if we try to increase the minimum and we'll keep the same maximum as before, so in this case we can get the better difference. So these two are the only subarrays that we can think of for now to get the maximum difference, and assuming the only operation is left. So firstly we'll select maximum minimum, and coming to second one, we will select two choices. Like we have two choices to select the same minimum and then the less maximum than the highest one, like second maximum element and then next smaller element and then most bigger element. So these two are the possible choices we have. So can we select next maximum and next minimum also? No, because even that will decrease our answer. So let's say we have 110 and the next smaller is 2 and the next is 4. So we'll select 210 here. But what if we select 2 and 4? It is very bad, because this is the range. We are increasing this also and we are increasing this also. So the range is going to reduce more. So this is very bad. So we have only two choices for every A. So if we have the subarray I and j with maximum and minimum, and then we have two choices, whether next minimum, maximum, minimum, next maximum. So now we got that we want some kind of arrays with indices such that v1 of I is more than v1 of I and more than v of 2 and so on. So here the main thing we want is the indices, not the values. But for example, if we store values, for example, we store 4 and 10 in the vector. So can we get that these are in the indices 1 and 2? No. But if we store the indices also, if we store indices 1, 2, then we can get indices also and then we can get values also. So it is better to store indices. So we want indices. So what are these both indices? So the first index is the index in one array such that it is sorted based on the values but in the inches. For example, let's say the array is 1, 2, 10, 3, 4. 1, 2, 10, 3, 4. Then what will be the array? The array should be 0, the array should be 2, 4, 3, 1, 0. So what is this? So 2. So v of 2 is the maximum number possible. What is 4? V of 4 is the next maximum value, which is 4. And coming to 3, it is 3. Coming to 1, it is 2. Coming to 0, it is 1. So we want this kind of array. Why we want? So that only then we can decide that this is the first index and this can be useful for other also in the next operations. So we want two kind of indices where the first one is 2 and 0. Like the first one is the indices with maximum value first, minimum value next, say third maximum values and similarly you want the other also where minimum. So you want other reverse vector also 0, 1, 3, 4, 2. We can reverse that directly, but we can store other vector also, saying that v of 0 is the least one, v of 1 is the second least one, v of 3 is the next least one, and so on. So if we have these both, then we have the pair I and j handy where we are doing the operation now. So we want these two vectors. So now after getting these two, what we want? Now we are selecting I and j. But how many number of arrays that are contributed for I and j? Because let's say there can be many different subarrays where this maximum value and this minimum value will be there. So that indirectly I and j will serve the purpose of selecting many different subarrays so that we can get the maximum different, like we can get the maximum answer. So the question is saying that we cannot select the same subarray more than once. But what if let's say we have I and j? So we have I and j. But what if there is subarray I and j plus 1 also such that I is maximum and j is minimum? So even then we are indirectly getting the maximum answer possible because I and j is the maximum ever answer possible. And if there is some subarray I and j plus 1, by selecting I and j plus 1, we are able to get this as the maximum answer. So this is what we exactly want. So now the main task is given 2 indices I and j. So given I and j, we have to find the maximum number of subarrays where we can achieve the same difference with I and j by selecting that subarrays. So given I and j, we want the number of subarrays. If subarray I and j plus 1 is also having the same answer as I and j. And when is that possible? Let's check that later. But for now, what is our main goal? Our main goal is given 2 indices I and j, we want the number of subarrays where selecting that is indirectly selecting I and j so that we are able to get the maximum answer possible. So how can you do that? Let's say I is maximum and j is minimum. So now we want how many different subarrays we can select. So let's say we have this I and j, and can we select some I and j here so that we will get this difference? No, because we can get I and j difference only if this subarray is inside the subarray that we are going to select, right? So let's say this is I and j we are thinking about. So if the new I is this and the new j is this, only then this can be inside and this can be reflected in the new subarray. If we select a subarray here, then obviously it will not reflect because I and j is not inside itself. If it is not inside itself, then how can we get that difference? So no. So if we have I and j, we have to think about subarrays with I less than the first I and j more than second I, so that this will be inside and then we can check if this contributes the answer itself. So for I, so let's say we have I. So what? So will this I be a possible I? Will this I be a possible I? Will this I be a possible I? Let's check that. For example, we have 7, 4. Let's say we have 7, 4. This is the maximum and this is minimum. So we have 2, 8, 1, 2, 1. So let's say this. So for this 7, can we, for 7, we are selecting 7, 4 first. So can we select 1 and 4? Obviously we can select because the same. So let's assume 0, right? So for now let's assume 0. So this will be best. We can select about the less element also after. For now let's assume that this is 7 and this is 0. So if we are selecting 7, 0, can we select 1, 0? We can select. Why we can select? Because the minimum is 0 itself and the maximum is 7 itself. So which will reflect 7 as answer. Even if we are taking other subarray 1, 0. So we can take 1, 0. So now the number of subarrays is 2. We can select 0, 7, we can select 1, 0 also. Can we select 2, 0 also? Yes, we can select 2, 0 also. Because even now the minimum is 0, the maximum is 7. And can we select 1, 0 again? Yes, we can select this also. And now, can we select 8, 0? Can we select this subarray? Where 8, 1, 2, 1, 7, 0? No, we cannot select this. Why we cannot select this? Because the maximum element is more than 7. Because for now we are assuming we are only taking I and j. So if we want only I and j, there should not be any other element which is more than the maximum element. But here the maximum element 7. But there is some element 8 which is greater than 7. So we cannot select 8. Okay, so what we got? So let's say this is the maximum and this is minimum. So given I, we can select only indices I such that they are after the previous greater element than I. So let's say this is 7 and this is the greater element. So this is 8. So the possibility of I can be any of these. So if this is the previous greater element, this means that all these are less than or equal to V of I. So we can include that in the subarray so that we can include I as answer. So we can get this as the maximum value. So given I, if we find the previous greater element, then we can select all the indices which are after than it and in the middle of I. And similarly for j. So let's say we have j and this is 0. So sorry, this is 1. So if this is 0 and this is 2, this is 3, this is 4, this is 1, 1. So if this is the case, for this one, let's say this is the result that we are selecting. So we can select this also, we can select this also, because the minimum element will be 1 itself. So this will contribute to our answer. Can we select this one? No, we cannot select this. Why? Because we got a new element which is less than the minimum element. So even now, given an index j, we can take only the indices till next greater element, less than greater element. So all these elements can be selected. So now, given an index I, the main thing is we want the previous greater, next greater. And for j, previous smaller and next smaller. So hope you got why we are selecting these two for greater and other two for more. And now we have to sell. So till now what we decided only for one index. So for one index I, we got the range of one index. But we want the subarrays, we want both for I and j. So we have to take the intersection of both. So let's say for I, this is fine, right? So for example, this is 3 and this is 7 and this is 10. So this is the next greater element. So we cannot select this and all middle can be selected. And for this is the next greater. This cannot be selected. All the middle can be selected. So for I, what is the net range of elements we can select? It will be pg plus 1 and ng minus 1. So for I, these are the possibilities. We can select any one from between these. And for j, all these are fine. Like for j, ps plus 1 to ns minus 1. But what about these intersection? So for these both, then like for these I and j, intersection will be answer. So we'll find the intersection and then we will get the number of subarrays that we can get from I and j. So now let's take example. So let's say we got this is k, this is it. Let's assume this is I and j, this is the maximum and this is minimum. So after taking the intersection, let's assume that this is the least one, this is the higher one. So if we take after than this, then either max or minimum will destroy it. Similarly for this. So I and q is the net range where we can select I and j. More precisely, we can select any I between I and k. We can select any j between n and q. And now what are the total number of subarrays? It will be simply 3 into 3 because we can select I any one from ijk and we can select j from any npq. So I and n is fine, I and p is fine, I and q is fine, j and n is fine, j and p, j and q, k and n, k and p and k and q. So total 9 are valid for I and j. So for a single I and j, we are getting the maximum difference as possible 9 times without selecting same subarray twice. So this is what we exactly want. So now we got the one possible answer where for the maximum difference, what are the total number of subarrays that can be taken. Now coming to next one. So we selected I1 and J1 array. So there is the maximum minimum. So we selected this. Now coming to next operation. So some arrays. So some from K are deducted because we will find the count. Let's assume that three subarrays can be achieved by I1 and J1. So K minus equal to 3. So K minus 3 subarrays are still left. And now, what will be the next choice we have? So we already discussed that we will select the subarray I1 and J2 or I2 and J1, so that only then we'll get the maximum answer possible. Because let's say this is the whole minimum and maximum. If we increase the next minimum, if we increase the minimum one, we'll get the better difference. Or if we decrease the maximum one, we will get the bigger difference. But if we try to decrease both, then we'll get least difference. So we'll select I1 same, or we'll select J1 same. I1 J2 will be new possibility, or J1 I2 will be new possibility. So now, which one we'll select? We cannot select randomly. We want the maximum answer possible. So we'll select I1 J2 or J1 I2. So that will depend. So that will depend on which one? That will depend on the difference that we are able to get from those both. So let's say, and also we can't blindly go. For example, let's say we got to 0, 1, 2, 3 for it. So now initially we got answer for 0, 1. And now we can take 0, 3 or 1, 4. And assume the difference for 0, 3 is 2 and the difference for 1, 4 is 6. So for now there are only two possibilities. So we can say that this is the maximum. So we can select this and we can proceed. But what if the operations are increasing? So let's say we got all this and we got 1, 4 also, and then we will get some other possibilities. So we can select 3, 2 or 4, 5. So the size will keep on increasing. So we cannot get which is maximum among all these, and we can do operation because time complexity will increase. So we want someone to say that given among all the possibilities, this is the maximum that is better. So this is the maximum one with difference. So given 10, it should be able to give an O of 1 what is the maximum difference we are able to get. And what is that? It is simply heap. So we can store the difference in max heap, so that even if we have 1000 different possibilities of subarrays to select, we will select the maximum one by O of log n. So we are using max priority queue, but priority queue of what? So simply priority queue of difference? No, because with priority queue we also want the integers that we are doing the operation, so that after this operation we can take I to j plus 1 or I plus 1 to j. So we want priority queue of difference and the pair of subarray that we are selecting. And also we have to make sure that same I and j is not taken again. So we have to hash this somewhere so that we are able to show that I and j we did not select. So we will use visited of I and j, visited of pair, but visited of pair is bad because it can go to n square, the space complexity can go to n square. So in this way, so there will be many different conditions where we have to get this. Given I and j, we have to get whether I and j is visited or not. But both can be bonified. So how can you do that? We can simply hash these into a single integer to store in set. So our main goal now is to, like, given I and j, we have to find the hash for this so that it will be unique for every pair I and j. What can we think of? So for now, if we assume that I and j are strings, so let's say I is high and j is by. So given these both, what will be the unique combination of these both? It will be simply high by. It is very simple, the concatenation, right? So with concatenation, we can add some comma in the middle. So if we add high comma by, so if we select high comma by, then this is the only possibility. This is the only configuration where we'll get this. Let's say we have HIB and YE. So if these are the strings, what will be the new hash? It will be HIB comma Y. So these are not same. So given I and j strings, we can simply add those both with comma in the middle, so that given I and j we'll get the single string. But what about integers? So what if we try to think integers as strings? So let's say this is I and this is j. So we want to make this both unique. So what if we try to shift I as much as right as possible and then insert j? So let's think of the binary. Let's say I is 1010 and j is 01. So this is I and this is j. So we want some integer value x such that both I and j are incorporated in this, and also for every I and j, x must be unique. Like this x should not come for any other I and j. So what can we think of now? So can we think of something like that? Something like this. So 1 0 1 0 and so on, like all are zeros, and then 0 1. So we are simply multiplying 1 0 1 0 by 2 power 32, and then we are adding j. Why we are doing this? Because in binary, if we multiply by 2, the whole will be shifted right once. If we multiply by 2 power 2, it will be shifted 2 by right left side. So let's say this is 1 0. We have 1 0 1. And if you multiply by 2, the new will be 1 0 1 0. So the string is moving left side and new 0 is getting added. If we multiply again this by 2, then what we'll get? We'll get 1 0 1 0 0. So if you multiply 2 power 32 times, so the whole string will be multiplied 2 power 32, and also we will get zeros all here. And then if we simply add j into this, the j will be incorporated in this. And as the numbers are all less than 2 power 32, we are sure that the j will include only these zeros. So I will not be destroyed. So now what we got? So we got that given I and j, which are both up to 1 if I, we can store 2 power 32 into I plus j as a single integer, so that both I and j can be uniquely added, and then we can use this for hashing also. So by this we can get how we are storing. And now we got all the things. So now let's check the code. So initially we want next smaller, next greater and all. So we can use for utility functions where these are already there. That's why I did not add especially. So these are simply stack, right? We can simply use a vector or stack, and then we can find. Hope you know how to find all those. So after finding these, we want two vectors where it will indicate the difference. For example, let's say the indices, the values are 3 4 2 1. So we want the first array such that it is 1 0 2 3, because v of 1 is maximum, then v of 0, then v of 2, and then v of 3. And then we also want for minimum where it will be 3 to 0. So how can we find this? We can simply store the value comma index, and then we can sort the vector of pair, and then we can sort based on the value, and then we can store the indices based on the maximum value in the new vector. So we'll store this in the vector, and then reverse this. So and then like sort this, and then find the maximum. Because we are finding the maximum, so we are reversing this, and then initialize mx of I as the index, and also push the back one. So after completing the mx1 mxi, we will get the maximum indices, and simply for minimum we can reverse that. So simply for mn of I, it is simply mx of reverse 1. And now let's think of priority queue. So given subarray, like given I and j, so given I and j, what we want? So we want whether this is already there in set or not. So how can we get? We can find this hash, and we can get whether this is there or not. And also after adding this, we also want how many number of subarrays that were considered because of this. So let's check add first. So add of 0 comma 0 comma a. So what is 0 comma 0? It is simply 0 is the index in mx of I. So mx of I is 0, we are considering, and mn of I is 0, we are considering, and a is the vector, and mx of I, mn of I are the vectors. And now we are adding this. So if they are more than n, then simply return, and we are finding the key, we are finding the unique hash value. And what is that? It will be simply 2 power 32 into I plus j. And now we are finding whether it is visited or not. If it is not visited, only then visit, and then add it into priority queue. And what is difference? It will be simply mx of I minus mn of I of j, and push I of j. So in this way we are adding into priority queue only if the I and j is not visited. So we have added this, and now start doing k operations. So while k greater than 0 and priority queue is not empty, so simply pop the first one, and then find the indices I and j. So what are the indices? We already showed in the priority queue where they are part of the second pair, second dot first and second dot second. So I and j are the range we are selecting, and we are finding the element. We are finding the original array indices also from this. So mx of I of im means the initial index in the vector where the maximum number, and j is the minimum. And for now we already fixed that I should be the maximum, j should be the minimum. So if this is not the case, then simply continue. We will do the operation only if I is maximum and j is minimum. So if v of I is less than v of j, then simply continue. Because if maximum is less than minimum, how is that possible? That is not possible, so simply continue. And if we are reaching this, it means that a of I is the maximum, a of j is the minimum. And now what we want? And now we have to check whether the difference is more than or equal to 0. Because there may be a possibility where the maximum difference among all will be 3. Will we do operation? No, because we can only add the answer. If we do this, the answer will reduce. So before doing operation, check if the difference is more than 0. So if more than 0, then do the operation. And what is the operation? The operation simply find the number of subarrays that are impacted because of this. And what will be that? It will be simply a minimum of k and the count of ing, because we can do only k operations maximum. So we are minimum capping the k and difference, like k and the number of subarrays that we can get from ing. And what is count of ing? The count of ing is simply that we discussed. So find the intersection of these both. How can you find intersection? Intersection is simply the maximum of these previous greater and previous small. So here we discussed that. So we are finding the maximum of these both, minimum of these both. So maximum of these previous greater, previous smaller, minimum of next greater, next smaller. And after this, find the net ing. So like after finding this, let's say this is the I and this is the j. So now we also discussed that we are doing the product of these. So we want this and these also. How can we find those? It will be very simply minimum of the ing and maximum of ing. Like for example, I is more than j, we are simply reversing those. So minimum of ing and max of ing. And after that we are doing the product for this. Difference plus 1 into difference plus 1. So ls minus l plus 1 into r minus rl plus 1. So in this way you are able to get the number of subarrays that maximum difference can be computed because of ing. And we are doing minimum because we can do only k operations in the maximum. And now what is the answer because of this? It will be simply the difference into number of subarrays. So current of first into k. And now we done these many operations. So what are the rest number of operations? It will be simply k minus into 10. And then if the operations are completed, if k is 0, then simply break. And then we have two choices. im plus 1 jm, im jm plus 1. So simply add these both into the priority queue. In this way, finally we can return the answer. If you have any doubts, comment below. See you in the next video.